Since the dawn of the earliest civilization, bridges have played an important role in the development of transportation and communication, spreading of knowledge, enhancing local and international trade. Bridges have overcome the obstacles created by water bodies. Bridges are links among the disconnected parts of land due to water. Thousands of years ago, men built bridges from wooden logs and tree trunks. Those bridges met the needs of that time, but by the gradual growth in communication, transportation, and trade volume, the need for larger and durable bridges started being felt. The doctrine of necessity worked, and science and technology also developed simultaneously. Bigger and advanced bridges started being constructed by the grace of civil engineering. From the time ancient till today, there have been tens of types of bridges classified on the basis of their design structure and materials used. Here are the most prominent materials for bridges. Concrete for bridges. More bridges are being built using concrete than any other material worldwide, demonstrating continued confidence in the material's performance and durability. Concrete bridges have a clear track record of flexibility and versatility in terms of both final forms and methods of construction that are hard to match. Durability, aesthetics, economic solutions, simplified construction, and rapid deployment techniques all contribute to making concrete the best construction material for any bridge project, whatever the size, form, or intended use. Greater construction flexibility can be realized through the many forms of concrete easily available nationwide, making concrete an adaptable resource suitable for deployment on even the most challenging of bridge types or construction sites. The range of structural forms achievable with concrete is limited only by the designer's imagination, enabling the creation of elegant bridge structures that blend seamlessly with natural surroundings. Concrete unites both function and elegance in safe, robust structures, regardless of scale. Architectural surface finishes can add to visual impacts, while at the same time eliminating the need for cladding, painting, and ongoing maintenance activities. Steel for bridges. Steel is widely used around the world for the construction of bridges from the very large to the very small. It is a versatile and effective material that provides efficient and sustainable solutions. Steel has long been recognized as the economic option for a range of bridges. Structural steel is a high-quality material that is readily available worldwide in certified grades, in products of various shapes and sizes. Prefabrication of steelwork in controlled factory conditions leads to high-quality work at minimum cost. The excellent quality control is achieved through a thorough testing regime at the steel mills and during fabrication processes of cutting and drilling, assembly, welding, and protective treatment. Steel material is supplied in two product forms: flat products, steel plate and strip, and long products, rolled sections, either standard open sections such as beams, channels, angles, etc., or hollow sections. For structural use in bridges, these products are inevitably cut to shape and size and welded one component to another. In the structure, the material is subject to tensile and compressive forces. Structural steel generally responds in a linear elastic manner up to the yield point and thereafter has a significant capacity for plastic straining before failure. All these aspects of steel material are utilized by the designer of a steel bridge. Cast iron bridges. Cast iron has a very high resistance to compression, which makes it ideal for use in arch bridges where the entire cast iron piece is put under compression. For this reason, the first large cast iron bridge, the Iron Bridge, used cast iron for its supportive arch. Cast iron columns for buildings had the advantage of being extremely slender compared with masonry columns capable of supporting similar weight. It's also useful in other kinds of buildings, for instance enabling architects of theaters, churches, and synagogues to improve straight lines when supporting balconies by eliminating or at least making the columns that support the roof of balconies thinner. Cast iron became a very popular construction material in the late 1700s. It had previously been too expensive to produce in large enough quantity for construction, but the advent of many new blast furnaces made cast iron more widely available. Though the Industrial Revolution cast iron bridges became very popular, and many still remain. Timber for bridges. A timber bridge or wooden bridge is a bridge that uses timber or wood as its principal structural material. One of the first forms of bridge, those of timber have been used since ancient times. The last 2 decades have seen a growing interest in timber bridges in many European countries. There are several reasons for this, and the growing interest in environmental questions and sustainability has definitely paved the road for more use of structural timber, but also new and innovative use of timber, such as the stress-laminated timber deck and better connections, have played an important role. Bridges are naturally divided into two major groups, footbridges and road bridges. The vast majority of timber footbridges have decks made of timber in one form or another, from simple timber boards or planks to crossed layers of boards and various types of laminated decks. For road bridges, the situation is more complex. It's very important to prevent surface water from penetrating the asphalt, wearing course, and some kind of impregnable membrane is therefore placed between the timber deck and the asphalt. Stone for bridges. Stone is strong in compression and somewhat so in shear, but cannot resist much force and tension. As a result, masonry arch bridges are designed to be constantly under compression, so far as is possible. Each arch is constructed over a temporary falsework frame, known as a centering. In the first compression arch bridges, a keystone in the middle of the bridge bore the weight of the rest of the bridge. The more weight that was put onto the bridge, the stronger its structure became. Stone bridges have been used in one form or another for many thousands of years. The earliest surviving stone structures were most likely based on clapper bridges. These are an ancient form of stone bridge formed by large, flat slabs of granite or schist supported on stone or resting on the banks of streams. Despite the expected high construction costs, the cost of masonry arch bridges appear to be similar to that of concrete or steel bridges. This is largely down to the lack of need for expensive machinery or equipment. Masonry bridges have always been built with predominantly manual labor and with relatively simple lifting equipment. The life cycle maintenance costs for masonry bridges are far lower than for other bridges, and if maintained properly, they can well outlast any other bridge type. For the time ancient till today, there have been tens of types of bridges classified on the basis of their design and the material used. Here are some of the most common. Beam bridges. Beam bridges are very common in the world. Reinforced concrete beams or stringers are placed on the piers of either concrete or brick. These bridges are easy to construct. It is also called a girder bridge because beams or girders of iron or steel are used. Arch bridges. Arch bridges are old-time bridges which are very common in Bosnia and Herzegovina. Live examples of such types of bridges are Old Bridge of Mostar, Bosnia and Herzegovina, Hell Gate Bridge of New York, Rialto Bridge of Italy, Ponte Vecchio Bridge of Italy, and Kaju Bridge of Iran. An arch bridge is constructed by utilizing the natural strength. The stones or bricks are compiled in the form of an arch in such a way that each of the brick exerts a force on the neighboring brick, thus strengthening the bonds among the bricks. Steel or iron is not used in an arch bridge. The half-circled arch is constructed only with the masonry work of bricks. This is an ancient method of construction in bridges. In the 19th century, metallic arch bridges got fame all around the world. Like a masonry arch, an arch made up of metal is installed under the bridge to give it full support. Truss structure bridges. In truss bridges, the load-bearing superstructure is composed of an assembly of beams or other elements that give turgidity to the structure. These bridges are economical and easy to construct and easy to dismantle. Suspended bridges. A suspension bridge is a masterpiece of civil engineering. The bridge is suspended by means of steel chain or ropes, which are firmly tied with the gigantic poles installed on either side of the bridges. Japan's Akashi Keikyo Bridge, San Francisco's Golden Gate Bridge, and China's Zihumen Bridge are good examples of suspended bridges. Indeed, these bridges are complex infrastructures and involve a lot of expertise to carefully construct. That was all from us today. For more similar content, make sure to subscribe to the channel. See you in the next one.